DJ Mixmaster HG. Here we go. One more beat. Super awesome. But now we have to learn chemistry. So I'm kind of going to get rid of that. So anywho, let's go ahead and take the notes. So title of these notes is going to be enthalpy. And now enthalpy is just a very fancy schmancy word for heat. H-E-A-T. Now, there are two main types of chemical reactions. So I'm going to say two types of chemical reactions. Now, the first type of chemical reaction is called an endothermic reaction. So the key to remembering what an endothermic reaction is this N. Kind of sounds like in, like inside. And endothermic reactions are positive, meaning we have to add heat. Now the formal definition of an endothermic reaction is need to put in heat to make the reaction work. So endothermic kind of looks like IN. It's your hint that you need to add heat. And endothermic reactions, they have a positive sign because we need to add the heat. Now some examples of an endothermic reaction are boiling water. Right? You have to add heat to boil water. So boiling water is endothermic. Also baking cookies. Right? You have to add heat in to bake cookies to make them cook. So that means that boiling water and baking cookies are both endothermic reactions. You have to add heat. The second type of reaction is an exothermic reaction. And the formal definition for that is basically heat is released when the reaction occurs. And the way I remember this is the X in front of exo, EX. Notice it kind of reminds you of exit. So exit, so I'm just going to say releases heat. And exothermic reactions, they have a negative sign. And this is how I remember it. Basically, pretend my arms are crossed in the X, exo. And notice if you collapse the X upon itself, it makes a negative sign. That's just sort of the weird way I remember that an exothermic reaction, we think of it as having a negative sign. So I look at my X, exo, and I just think of the X collapsing upon itself to make the negative. Endothermic reactions have a positive sign. Exothermic reactions are releasing heat. They have a negative sign. Now, I'm going to draw two graphs to illustrate these reactions. 1, 2. So you can see I've drawn two of them. Now, the first one, I'm going to draw an endothermic reaction. So let's write endothermic exothermic under it. And the graph of an endothermic reaction looks like so. Now, on the x-axis is reaction progress. On the y-axis, that is heat energy, and that is in joules. On the first line is reactants, and on the second line is products. So basically, this reaction progress is maybe the time. Maybe this is 5 minutes, 10 minutes, 20 minutes, 25 minutes. I know those aren't correct intervals, but you guys get the idea. So at 5 minutes, I still have reactants. And as time goes by, notice I'm increasing my amount of heat. Heat's on the y-axis here. So I'm increasing my amount of heat, and after about 25 minutes, I get my products. So let's pretend that this value right here is 20 joules, and this value down here that the reactants are starting at is 10 joules. So notice I went from 10 joules, that's where I start with my reactants, and I ended at 20 joules. That's where I end with my products. So there was definitely an increase in the heat to go from reactants to products. And so I'm just going to draw a little squiggly line like so, and I'm going to write increase in heat. That's, quote, endothermic. Going to write a positive sign and then say add. Okay, to get from the reactants, from what I start with, to my products, what I end with, I have to add heat. And I can see that heat started at about 10, and notice it went to 20. So that's endothermic. Now the second type of reaction is an exothermic reaction. So I'm going to go ahead and write exothermic underneath. Same labels. This is reaction progress on the y-axis, or sorry, the x-axis. Ask me for a point tomorrow for messing that up. And heat energy is on the y-axis. And that is in units of joules. I'm just going to write capital J. So the reaction progress for an exothermic reaction looks a lot like this, where reactants are on the y-axis, or reactants are what we start with, and products are what we end with. Now notice it's a little bit opposite. Notice the reactants start higher than the products. So let's just pretend that this value right here for heat energy is 20 joules. And let's just pretend that this value down here for heat energy is 10 joules. So notice our reactant started at a heat of 20 joules, and the reaction happened 5 minutes, 10 minutes, 12 minutes, 13 minutes, 14 minutes, 15 minutes pass, and I get to my products. And notice the products are at a lower value of heat. They're at 10 joules. So notice I started at 20, but I'm ending at 10. This is an exothermic reaction because there's a release of heat. I went from 20 down to 10. So I'm going to draw a little squiggly line from reactants to products, and I can see that there was a decrease / release of heat. That is exo, therefore it's a negative sign. When you are releasing heat, notice you went from 20 joules to 10 joules. When you are releasing an amount of heat, that is an exothermic reaction, that is a negative sign. The negative represents the release of heat. Last thing, we're just going to do one definition. Enthalpy. And enthalpy is abbreviated by H. That's its coefficient, not the coefficient, that is the coordinate, not coordinate. That is basically what they use in algebra to plug things into. I can't think of the word right now. Anyways, enthalpy is just the heat of a system at a constant pressure. I guess we could say H is the variable they use for enthalpy. Instead of an E or an N, they use the H. And that's kind of helpful because enthalpy is just a very fancy word for heat. So once again, two types of reactions. Endothermic, heat needs to go in. Notice to go from reactants to products, I had to add heat, lower value, higher value. Second type of reaction is an exothermic reaction. Heat's released when the reaction happens. Notice reactants, and then I have my products. So as the reaction's happening, I end up at a lower value for heat than I started with. That means heat is released. We will go over this a lot more tomorrow and a lot more on Tuesday, so don't worry about it. So hopefully I'll see you guys tomorrow.